So good morning, learner. Welcome to today's math lesson, which is going to be cross-sectional area of cylinders, as I told you in our previous lesson. But before we do this, learner, we need to understand what a cylinder is. So a cylinder is going to be something I'm going to draw here. It's going to be a figure that looks like this. That is what we call a cylinder. So a cylinder is a shape, just the shape of a drum that you might have seen. Back at home, we have drums or a bucket. That is a good example of a cylinder. If you look at this cylinder, learner, it has two parts. There is the circular parts. We can place it like this, learner. So the bottom part also is a circular one. So there are two circular parts. And there is this part here in between. This part, which looks like a curved surface. There's a curved surface and two other circular parts. So that is exactly what we call a cylinder. So for us to be able to calculate the volume, the cross-sectional area of a cylinder, we are basically looking at this part. How do we calculate the area of that part? So that is what we call the cross-sectional area of a cylinder. So how do we get that? Now if you look at that part, that part looks like a circle. And so we are definitely asked to calculate the area of a circle. So how do we calculate that? Remember, we have done that in our previous lessons. How to get area of a circle. So if this circle, I taught you circles in class 6, and we said a circle looks like this. And in a circle, there are things we call sectors. Look at this one. We call this a sector. Part of a circle. That part is called a sector. So we call this a minor sector, and this bigger part, which is not shaded, is called a major sector. So these parts of a circle are called sectors. You might be asked this in an exam, so we call sectors. So away from that, we want to understand how we get area, because we are looking at the cross-sectional area. So I'm going to draw one cylinder here, and that cylinder is having a radius. What do we call a radius, learner? If you have a circle like that, the distance from the center to the circumference, we call this the circumference of a circle. That circular part. So if you go around, you move from this point X, go around and come back point X, you will have completed one lap of that particular circle. So you call that circumference. So radius is the distance from the center to the circumference. But again, we have the distance from the center to the circumference through, or we can call it the distance from the circumference through the center to the circumference. That line we call it diameter. I want you to get these things because we are going to be given questions that involve a diameter and a radius. So for us to be able to understand what we are going to use, you must understand this first. So this is what we call a diameter. If you want to get radius from a diameter, you get diameter, we divide that diameter by 2, you get radius. Assuming this was 14 centimeters, if you want radius, meaning that you want just half of that circle from here, center, downwards. That is what we call a radius. So a radius plus another radius from here to here, you get a diameter. So if you want to get a radius, you get diameter, divide that by 2. So assuming this is 14, for us to get the distance from here to here, you divide that by 2, and you realize it's 14 over 2, which is 7. So here is 7. So that's when you add 7 plus 7, you get 14. So either way, this direction or this one, you still get the diameter. So we are given we are given a radius of this particular figure being can be given 7 centimeters. So the radius is 7 centimeters. And maybe you ask, we told this is 10 centimeters. You're calculating first. If you want to get, if you ask the volume, you must get first the cross-sectional area. So we say volume, you must get cross-sectional area times the height. If we place this one in a standing position, you realize that this 10 is here. So that becomes the perpendicular height. And then this radius is there, 7 centimeters. So if you want to get the volume, you first calculate the cross-sectional area, which is the area of the circular path. How do you calculate area of a circle, Lana? Area of a circle is calculated by pi r squared. Pi r squared. Pi r squared means, and the pi can be either 3.14 or 22/7. You're asking why you're getting this 3.14. If you take 22 divided by 7, you get this. So this is a ratio, a decimal pi. This is a fractional pi. So in an exam, if you are given this to use this, kindly use this. If you use this, you get a different answer, which may not be there in that particular question. So for us to be able to get the cross-sectional area, we get pi r squared. So the area will be equal to pi 22/7. The radius squared means radius times radius. So the radius is 7. So 7 times 7. That is what we mean by radius squared. Radius squared, 7 times 7. So by 7 1 by 7 1, 22 times 7 is 154. So it's 154 centimeters squared. Remember we're looking for cross-sectional area, and area given is given in square units. So this is going to be 154 centimeters squared. Now if you ask volume, the volume of the cylinder will be equal to cross-sectional area times height. So that is going to be, volume is equal to, we have the cross-sectional area. So 154 centimeters squared times the height is 10. Just multiply that by 10. And this is going to give you 1,540 centimeters cubed. Because what we are looking for is volume now. So in brief, to be able to get the volume of a cylinder, you get cross-sectional area, that's the area of the circle times the height. Very, very important. So how do we get area of a circle? Pi r squared h. And therefore, the formula for getting or calculating volume of a cylinder. When you write this, Lana, of a cylinder will be equal to pi r squared. What is pi r squared? The cross-sectional area of the circle times height. Very, very important. So anytime you are getting area of a volume of a cylinder, you just say volume is equal to pi r squared h. That is what will give you the volume. Now let's do some questions here to be able to understand exactly what we are doing. So a cylinder, let me write a question here. A cylinder has a radius of 49. A cylinder has a radius of 49 centimeters. Its height is 1.5. Its height is 2.5 meters. Sorry, I'm talking about centimeters and meters. Yes, meters and centimeters. So question number 1, what is the cross-sectional area of the cylinder? A. What is the cross-sectional area? Area of the cylinder. What is the cross-sectional area of the cylinder? How do we get cross-sectional area, Lana? We get cross-sectional area by getting the area of the circular part. So cross-sectional area is calculated by pi r squared. And therefore, 22 over 7, we are told to use the pi 22 over 7. Therefore, 22 over 7 times the radius. What is the radius? Is 49. So 49 squared. 717. This is going to give you 154. So 154 times 9. 154. If you multiply 154 times 9, you are going to get 7,546 centimeters squared. So that is going to be the cross-sectional area. Question number 2 of that particular question, that is B. Part B of that question says, what is the volume of the cylinder? B. What is the volume of the cylinder? And therefore, volume is replaced by cross-sectional area times the height. And therefore, volume is going to be, the cross-sectional area is 7,546 centimeters squared times, Lana, if you look at our question here, the radius is given in centimeters, but this is given in meters. So we are going to change this into centimeters also. So how do we change? So if 1 meter is equivalent to 100 centimeters, what about 2.5 meters? Will be equal to how many centimeters? So you cross multiply. Simply 2.5 meters times 100 centimeters. So you're going to remove this and say this 5 over 2 times 100. This is going to be 50. And so this is going to be 250 centimeters. 250 centimeters. 5 times 50 is 250. And therefore, our answer is going to be 1,886,500 centimeters cubed. That is in centimeters cubed. Or if you change this to be meters, then it means that your answer is going to be in meters cubed. Therefore, you are going to divide simply this by 1 million, and you're going to get 1.8865 meters cubed. Because 1 cubic meter is 1 million centimeters squared. So that's how we get it learned. So remember the formula, volume is equals to pi r squared. This is very, very important. That's the area of formula of getting the volume of a cylinder. Maybe I do the last one and I'll give you a few example questions here to do. An oil tank, an oil tank, an oil tank, an oil tank is 3.5 meters in diameter. And 14 meters long. 14 meters long. So this length in our case is going to be the height. What is the volume of the tank? What is the volume of the tank? What is the volume of the tank? So you're going to realize that in this case, we are required, maybe even draw. If you drawing is very comfortable for you, you are supposed to do it. So an oil tank is 3.5 meters in diameter. So the diameter is 3.5. Indicate there 3.5. And 14 meters long. So the height is going to be 14 meters. So the question is volume. How do you get volume? Pi r squared, which pi 22 over 7. The radius. Now the radius is this divided by 2. Because this is diameter. How do you get, if you have diameter, how do you get radius? You get the diameter divided by 2, you get a radius. So I'm going to put it as 3.5 over 2. I don't want to continue dividing here and get so many decimal points. So I'm going to get diameter over 2 times diameter over 2 times the height, which is 14. Now, if you take diameter over 2, multiplied by diameter over 2, same as radius times radius. Because how do we get radius? Taking diameter dividing by 2. So you will take diameter over 2 times diameter over 2, you are getting just multiplying radius times radius. Because if we add diameter of 14 and we divide by 2, is 7. So 14 over 2 is simply 7. So you can make that remain with it as a 14 over 2. So by 7 over 7, you have 0.5. Now there are those people who multiply here and say by 7 1 by 7 5. This is not 5 because 7 cannot get into 3. So it gets into 3 0 times. So you move this 3 to become that 5. That's why you say 7 here by 7, 0 point. Then this 3 moves here to become that 5. So 7 gets into that 5 times. So it's not 5 because 7 cannot get into 3. Remember this 3 point, it is not that 5, it is 3.5. So here it gets 0 times. Then you move this 3 here. The same here. So by 2 1, by 2 11, then by 2 1, by 2 7. So you're going to have 11 times 0.5 times 35 times 7. So what you can do down here is multiply 11 times 5, ignoring the decimal point, you get 55. So 55 times 35, you get 5, 27. You get 5 and 1, 16. Going to get 5, 2, 9, 1. So 19, 25. Now multiply by this 7. 5 and 3. 5 and 3. This is going to be 14, 17 and 1. 63 plus 1, 64 and 6. This is going to be 13. Then how many decimal points we have? 1, 2. So 1, 2. That is going to be 104.75. Well, this centimeters, no, meters. So meters cubed. That is going to be the volume of that particular cylinder, cylindrical tank. So that's how we do it clearly. So long as you have the formula here, and sometimes you can be told use the formula the pipe 3.14. Don't use another one. If you use the other one, you over 7 because you think it's very easy for you to work with, you are going to get a rough answer. So now I want to give you work here. I want you to attempt exercise 86. Exercise 86. That was on page 143. They ask questions running from number 1 to 4. So I want you to attend these questions and ensure that you post them back to me for marking so that you can be able to understand exactly what you are doing. So until next time, learner, I want to wish you well. Have a very blessed day and a busy day back at home. Ensure you do those questions well and post to me for marking. Have a blessed day.